Awesome. Okay. So here we have a man for Halt Catch Fire, but we've got a couple characters here. This is welcome to Mutiny. Mutiny is a startup that makes in the show that makes games, specifically online games, like a tank battle where you're playing with somebody on the other side of the world. Really cool stuff. And I can't remember people's names now. Totally blanking. Cameron, yes, Cameron runs Mutiny. Awesome. We've got Brian over here, his wife Donna, and Joe. Now, Mutiny has a problem. They've got servers strewn all over their house, like more servers than you could imagine. And they still can't keep up with their user traffic. And the server fails here, and now all their users are mad because everything's going down. Gordon, on the other hand, works for West Group Energy. And West Group Energy has lots and lots of mainframes. And they use them for processing all their business data. And they run 9 a.m. to 5 p.m. and then they shut off. But they spent hundreds of thousands of dollars on these mainframes, and they're sitting idle most of the time. So Gordon and Joe came up with an idea. We've got mainframes, we've got code. Give us your code and we'll run it on our mainframes. Very simple. Our servers are down most of the time, so we can let you use that computing power in order to run your applications. So this chart gives you a bit of a breakdown of different ways that you can run your infrastructure. So all the way over here on the left, we have on-premises. You are responsible for everything. You buy a server, you set it up somewhere, you wire it up. We've got infrastructure as a service where they give you all the hardware and some virtualization and stuff so that you can go ahead and throw your operating system and runtime and application and everything in there. We've got platform as a service where all that's taken care of. You upload your application, you handle your data. That's awesome. And then we've got service as a service all the way on the other end where you literally don't have to do anything. You create an account, you're ready to go. So we went from this original mainframe time-sharing idea. And it's evolved over time where you can kind of pick and choose how much you want to run yourself and how much you want to be somebody else's responsibility. So let's talk about serverless. As you can see here, the main major cloud providers, Google, Amazon, and Microsoft, all have plenty of serverless services. Can everybody read this? Is that a little small? So I'm going to talk about Google Cloud. So we've got cloud functions, which allow you to break down your code not just to the application level, but to a function level and deploy those functions individually. We've got cloud endpoints, which we're not really going to talk about. They allow you to hook up a URL to trigger that function. Fire-based authentication gets over to the service as a service side of things, where it's an API. You send in an email address and password and say, hey, register this person and give me a user ID. And when you log in, you send it to them and you say, hey, does this match? Give me the user ID for that. Cloud Firestore is a NoSQL database. Again, it's just got an HTTP or a gRPC API. You just talk to it, they handle everything. Cloud PubSub is the same thing for asynchronous messaging. Cloud storage is the same thing for file storage. And App Engine is kind of like Cloud Functions, but it's more of an entire application kind of thing. So slightly lower level there, but still serverless, still ephemeral, still you don't have to manage anything. So let's take a look at some of the hard common components. Things that we have to write in all of our apps that we shouldn't have to write. Because this problem has been solved like I'd say 1,000 times, but it's really like millions of times. Like people have written authentication so many times. Everybody's had to deal, or everybody who's dealt with a system at scale had to deal with some sort of database sharding, scaling, cluster management, all this stuff. Nobody wants to do it. There's some service ops guys who love that stuff. So kudos to you. I don't deal with that. SSL. Like the worst message I ever get is our SSL certificate expired and now people are complaining. Queuing, message passing stuff. I want to be able to send messages. I don't care how they get there. And file storage, the same thing. I just want these things. I don't want to care about them. Let's take it a step further. Your whole server, your database, the ability to deploy with one click, monitoring and logging, A/B testing, all these things. Every app just needs them. I don't want to have to deal with that. So we keep building things over and over. Let's focus on our business requirements. Let's write code that fulfills the things that our business is trying to do. Delegate all the dev and ops stuff, common components to third parties who can leverage their scale. You know, Google's already got billions of users. Give them your 100,000, like it's okay. So let's take a look at what our architecture ends up looking like. So we've got Cloud Firestore is going to be our database. Google PubSub is our messaging, Firebase Auth, and cloud storage. And it all plugs into all our little cloud functions over here in the middle. Or in other words, not my business, not my business, not my business. We got my business here in the middle. So that's really what I'm going for. I really want to write code that looks like this. When a request is made to users, do send a user object in response. When a request is made for posts, just send a post. You know, define what a post is in your code, but you know, really responding to events and not writing a server that sits there as infinitely waiting for a request to come in. Like nobody cares about that. You know, as far as triggering off of events, when a new post is created, index that post. These are things that should be simple. Now, kind of skipping ahead, but these things exist. You know, cloud functions exist. My problem with cloud functions really comes down to, if you want to use cloud functions as Google Cloud Functions, you gotta write a lot of YAML. It's very hard to tie the things together, and it's like really raw and bare bones. On the other hand, you can go use Firestore to deploy your cloud function, or Firebase to deploy your cloud functions, where you just have a single index.js file. You say module.exports.myfunction equals this function, and you just tie 1,000 functions together over there, and now you've got your whole system. The problem is that service boundaries are important, and your service boundaries start to break down when you start to make everything easier to deploy by integrating it all together. And by creating isolated views of code, we're able to keep less on our head at a time. So I don't want to really be tying everything in at one point, but I want to tie everything in at one point so that I can deploy it all together. So I had this crazy idea. Let's create service config files without YAML, because I hate YAML. So can everybody read this? Is it a little too small?
Can't read it.
All right, let me see if I can zoom in a little bit. No. That's what you get for using Carbon. I love Carbon, but that's what you get for using Carbon. All right. So I'm just trying to get through it anyway. Over here at the top, we're importing the schema for this service. Then we're importing a couple functions, list post, index post, and decide featured post from a lib file. This can be anything. I don't usually write it exactly like that or structure it like that, but the point is that as long as you can get it into this object that we're exporting, it's good. We declare a base path for our service. This is like a namespace, so if we're hitting our API URL, /posts would get us to the service. Resource path essentially says where in Cloud Firestore we're storing the documents for this service. So let's say we have a posts object, and they're all stored in the posts collection, you know, keyed by the ID of that post. So this is a Cloud Firestore syntax for it. That's a variable. That's a constant. Publish changes true. When you declare that, what it will do is listen to all of the changes that happen to documents in that collection and publish those changes out as messages to Cloud PubSub or any of your other services can listen to that. So they can listen to changes that happen to data on other services. We're going to include our schema over there, and then we're going to declare, in this case, 3 sections of events. They're divvied up by, we have routes as our HTTP events. Those are synchronous. Events is PubSub messages that are going to come in. They can be database changes because we broadcast those through Google PubSub or actual messages that are published over PubSub. And then we have schedule over here, which defines cron job. So Google Cloud recently released the ability to time essentially the publishing of messages, but really the execution of functions. So we're able to take advantage of that, and using the app engine syntax for scheduling these things, it's as easy as saying time every day. You don't even have to know like Unix croncat syntax. So we create these arrays of little objects that describe how our functions integrate into our services. So in this case, when a GET request is made to this path, the function list post is going to run. We can add authentication middleware as well, where we would be able to say like privilege would be author, and then if the user's not an author and their user ID doesn't match the user ID that's attached to this post, we can deny them access to that. But those are all things that you can build that easily tie into this. A schema definition for a service like this looks like this. It's an object with the keys are the different fields that we can have in our document. In this case, title is going to be a string that's required. Same thing with description and body. Tags is a little more interesting because tags is an array of strings, and we want to make sure that they're lowercase. So we're going to say that it is an object because in JavaScript arrays are objects. It's not required, and it's going to default to an empty array if it's not given to us. We have a validator function that takes the value and checks if it's an array. And then we have a write modifier function that allows us to enforce certain things about the value there, and we are going to map over this array and change everything to lowercase. Author is going to be an object, and we can use a validator that just makes sure it has a name, email, and user ID property. So this gives us, a really easy way to tie all of our Google Cloud functions together and to deploy them easily, still be able to really understand how they integrate. Because if you're in any part of the code base, look for the index.js file in there. You'll be able to look at the service definition and the schema very easily and figure out kind of what's going on in that corner of the system. So let's take a look at what some of this looks like in practice. Let's see if I can bump the size of things up here a little bit. Here. Do that. Is that readable? Yeah. Okay. So to get started, we'll see if Google comes after me for this, but it's called Firebase Framework. So to get started, you just npm install Firebase Framework. You also need if you look for it on npm, there's an extensive README that explains how to get started. I haven't built a CLI that scaffolds things out for you yet. Let's see. Let's go to, there we go. All right, so this is where it all starts in our index.js file. So I don't know, who here has written Firebase code before? Nobody. One or two. Awesome. Cool. All right. So the way a Firebase index.js usually looks is that you start by calling admin.initializeApp. That gets your admin instance running. You give it the database URL and the service account certificate, which authorizes your stuff with your project. We have this, and then you would do module.exports equals an object that's all your different functions. In this case, we create this config object, which I'm going real bare bones here, is empty. This is how you would inject middleware and things like that, authorization middleware and other request middleware into the framework. And we're going to call create functions, give it our config object, and an array of services. Those services are defined over here in services.js, and it's just import test and then export an array of them. Just gives you a good place to get just a list of all those services. So if I look at our test service, this is a slightly more stripped down version of that configuration that we saw earlier. We just have a base path, schema, and routes. And we have a get and a post over here, and then we have an event that's listening on the hello topic, and it's going to run the hello message function. So, we do have a schema. Yeah. We have a message which is going to be a string, and it has to have a length that's greater than 0, and it's required. Over here, hello world, this is going to be an HTTP. You're going to learn this is, so Firebase uses under the hood Express.js for all of its routing and request and response objects. The one gripe I have with with Express.js is that I can't like return a tag tuple to indicate a response. I have to call like response.status.send. And when you're working in serverless environments, where as soon as you send that response, all your code is gone, like disappears. It's really good to like make somebody return from the function so that they realize that everything here is gone. So I wrote a little wrapper that allows you to return like 200, and then that's the status code. Here we have our request body, and if I wanted to add some headers, I could do that over there as well. You can always take that response object that's being passed in, use that to send things. If you want to like override it, it'll realize that and it'll cut off the connection once the function returns. But it does clean it up a little bit. In this case, this is our post handler. It's going to publish a message on the topic hello, and you just give it this object over here. There's two pub sub utilities. One handles parsing a message, one handles sending a message, and that's really because for some reason Google makes you encode your message to base 64 before sending it and decode it instead of them doing that automatically. That would be great. So yeah, this is what I've been working on for the past couple months. It's been a lot of fun. So how do you get started? Let's see if I can ever get out of this. There we go. All right. So Firebase framework over here on NPM. Follow the starter guide. NPM install -g Firebase tools, which lets you interact with Firebase, and then you NPM install the Firebase framework, and just take it from there. So this is like, I'm the only person who's used this so far. My company's the only company that's used this so far. I'm just putting this out as open source right now. That was my, giving this talk was my motivation to do that. So feel free to tinker with it, play with it here and there. If somebody here uses it and they have any questions, feel free to contact me. I think it's really cool. Hopefully I can get some feedback from you guys, and who knows, maybe this will actually turn into something that people use. All right, that's all I got for you. Thank you so much.